When we gaze up at the night sky, it's easy to imagine the vastness of space as a tapestry dotted with stars, each one potentially hosting its own system of planets and moons. For centuries, the search for life beyond Earth has been fueled by questions about these distant worlds. In recent decades, the discovery of thousands of exoplanets, planets orbiting stars other than our Sun, has expanded our horizons and deepened our curiosity. But an exciting new chapter in the search is unfolding: the hunt for habitable moons. While most attention has focused on finding Earth-like planets, many astronomers and astrobiologists now believe that moons orbiting giant planets, so-called exomoons, could also be prime candidates for life. But what are the actual chances that such habitable moons exist? To understand this, let's first consider what makes a world habitable, and then explore the evidence and possibilities for moons beyond our solar system. Habitability, at its core, is about the conditions necessary to support life as we know it. The most fundamental requirement is liquid water, which in turn depends on a world's temperature and atmospheric pressure. On Earth, water exists in all three states, but life thrives where it's liquid: oceans, rivers, lakes, and even underground reservoirs. To maintain these conditions, a planet or moon needs to be within the habitable zone of its star. Not too hot, not too cold, but just right for water to persist. But temperature isn't the only factor. A world's atmosphere, magnetic field, chemical makeup, and even its geological activity all play roles in sustaining life. And as we look beyond Earth, we find intriguing hints that moons might meet some, or even all, of these criteria. Within our own solar system, moons like Europa, Enceladus, and Titan offer compelling examples. Europa, one of Jupiter's 4 largest moons, is slightly smaller than Earth's own moon, but beneath its icy crust lies a global ocean of liquid water. Geysers of water vapor have been observed erupting from its surface, hinting at possible hydrothermal activity on the ocean floor. Enceladus, a tiny moon of Saturn, exhibits similar plumes, and its subsurface ocean is thought to be salty and possibly rich in organic molecules. Titan, Saturn's largest moon, has lakes and rivers, not of water, but of liquid methane and ethane, and a thick, nitrogen-rich atmosphere. None of these moons is exactly like Earth, but they illustrate the diversity of environments where life could potentially take root. If such moons exist in our solar system, could they be common elsewhere? The answer depends on a few key factors. First, how frequently do giant planets, like Jupiter and Saturn, form around other stars? Observations with telescopes like Kepler and TESS have revealed that gas giants are fairly common, especially around sun-like stars. Where there are giant planets, moons are likely to follow. In our solar system, Jupiter and Saturn together have over 160 confirmed moons. It's reasonable to expect that exoplanetary systems host their own families of moons. Second, can these moons be big enough to retain atmospheres or generate internal heat? In our solar system, most moons are small, but there's no reason nature couldn't produce larger ones, so-called supermoons. If a moon is massive enough, it can hold on to a substantial atmosphere, potentially allowing for stable climates and liquid water on the surface. Additionally, the gravitational pull from its parent planet can cause tidal heating, internal friction that keeps the moon warm, even if it's far from the warmth of its star. This tidal heating is crucial. It means that a moon doesn't have to be in the traditional habitable zone to have liquid water. Europa and Enceladus are far from the sun, yet their oceans are kept liquid by the constant flexing and squeezing from their giant hosts. If similar processes occur in exomoons, the range of potentially habitable environments in the galaxy expands dramatically. But what about the challenges? For one, large planets often have strong magnetic fields and intense radiation belts. A moon too close to such a planet could be bombarded with harmful radiation, making life as we know it difficult. However, an atmosphere or a magnetic field of its own could offer protection. And while tidal heating is beneficial, too much of it could lead to volcanic activity or even turn the surface into a molten wasteland. So, what do the numbers say about the odds of finding habitable moons? While we haven't yet confirmed the existence of any exomoons, the search is intensifying. Advanced telescopes and detection methods are beginning to uncover tantalizing hints. In 2017, astronomers announced the possible discovery of a Neptune-sized exomoon orbiting a Jupiter-sized planet about 8,000 light-years away. Though this candidate remains unconfirmed, it demonstrates that the technology is reaching the necessary sensitivity. Statistical models suggest that if exomoons form as commonly as moons in our own solar system, there could be billions of them in the Milky Way alone. Even if only a small fraction are large enough and have the right conditions, that still leaves a vast number of potential habitats. And because moons can be heated both by their star and by tidal forces, they might outnumber planets as potential abodes for life. The search for habitable moons is still in its infancy. Missions like the James Webb Space Telescope and upcoming observatories will improve our ability to detect and study distant moons. Meanwhile, robotic missions to Europa and Enceladus are planned to directly sample these intriguing environments, searching for signs of life in our cosmic backyard. In the grand tapestry of the universe, habitable moons may be hiding in plain sight, worlds with underground oceans, protective atmospheres, and the energy needed to support life. The odds are not certain, but they are far from zero. As our tools and understanding improve, the chances of discovering a habitable moon, and perhaps even life itself, grow stronger with every passing year. The next time you look up at the night sky, imagine not just the planets orbiting distant stars, but the secret worlds circling them, waiting to be explored.